What's up geeks, and welcome to the channel. In this video we're going to introduce another paradigm called backtracking, and this algorithm is implemented with the help of recursion. So I strongly suggest you have a very good understanding of recursion before proceeding with this one. Okay, so backtracking is a general algorithm for finding all or some solutions to some computational problems, notably constraint satisfaction problems or CSPs like Sudoku for example. To do that, this algorithm incrementally builds candidates to the solution and abandons a candidate or backtracks as soon as it determines that the candidate can't lead to a valid solution. To make things easier, you can imagine the procedure of backtracking as a tree traversal. We start from the root node and set out to search for solutions located at the leaf nodes. Each intermediate node represents a partial candidate solution that could potentially lead us to a final valid solution. Once we determine that a certain node cannot possibly lead to a valid solution, we abandon that node and backtrack to its parent to explore other paths. Okay, let's try to visualize this concept and suppose we are given a set of words represented in the form of a tree. The tree is formed such that every branch ends in a word. Our task is to find out if a given word is present in the tree, so let's say we must search for the word life. A very brute way would be to DFS all the paths, find out the word corresponding to each path and compare it with the word life. We'll keep doing this until we find the word we are looking for. In the tree you see our brute force approach had to go down 5 paths and 11 nodes before it finally found the right branch for the word life. On the other hand, the backtracking way of solving this problem would stop going down a path and backtracks as soon as this path does not seem right. In this example we will start at the root, and as soon as we visit its left child we will notice that all the paths this node leads to will not generate the desired result. Because of this, we backtrack. We go back to the previous node or its parent node and take the next step, i.e. visit the right child of the root directly without having to go through all the left child's children. In the example we have backtracking reduced the number of nodes visited to reach the result from 11 to 6, which is nearly half, and this is known as pruning the recursion tree, because we are not visiting unnecessary paths. Now, before attempting to implement any backtracking algorithm, let's try to come up with a small template, a pseudocode that we will be able to use with almost all our backtracking problems. So, our backtrack method should at least be given the target we are looking for, which in our example was the word life, and the list of candidates we are supposed to be searching in. Previously, this was the tree of characters. Okay, we already know that this method is going to be a recursive one, and it will be used to traverse the different paths we have in the tree. So what we need is some sort of variable that allows us to keep track of the current path under traversal, and as soon as the path we are traversing matches the target we are looking for, then we can update our answer and end the recursion. Now, to modify the path currently being traversed, we need to iterate through all our candidates within this method. And if the current candidate at hand is valid, we can go ahead and add it to our current path. At this point, what we need to do is call the backtrack method again, allowing us to explore this path further, as until now it may very well lead us to the result we want. If that inner call returns without having found the answer we are looking for, then what we need to do is remove that candidate from our potential answer. In other terms, we need to backtrack to its parent. And that's it. This template will help you solve most of the backtracking questions you'll encounter. I know it's a little bit tough to grasp this concept right from the first time, so do not worry, we will be solving and implementing a lot of backtracking problems in the upcoming videos of this series. Let me know your thoughts and suggestions in the comment section. And that's it for today. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.